Okay, I mentioned in class that I'll show some examples as videos. So we had the lesson today in class on finding volume. So your examples, your homework is about finding volume. So I've just got 3 examples here that kind of give us a gist, so if you need a little bit of help. I want to find the volume of this 3-dimensional figure, okay? Now, notice that this is not a figure that we're familiar with, but it is a C&P flat top. Because it's a C&P flat top, we can find the volume by simply taking the area of the base and multiplying it by the height. So the area of the base is all that is yellow, if you can picture that. All that is yellow is the base, and this distance here is the height. So this is the height, which we can see that to be 1.5 centimeters. So that's my height. So now we're back to our last chapter shenanigans to find the volume of that yellow base. You could break it into all kinds of different rectangles, but I choose to look at the large rectangle and then subtract out what I don't want. So I see this is 5 times 2, so this is 10 centimeters squared. Don't want that. And this is 2 times 2, which is 4 centimeters squared. We're going to subtract that away from the large rectangle. So the area of the large rectangle is equal to, let's see, that's 7, 9, and 3, 12. 12 centimeters times my height, EF, of that rectangle is 8 centimeters. So I've got 8 times 12 to get 96 centimeters squared. And now I want to subtract out the 10 centimeters. Want to get rid of him and want to get rid of that guy there. So I'm going to, to find the, I'm going to call it big B, area of the base is going to be 96 centimeters squared. Take away 4 centimeters squared. Take away 10 centimeters squared. So when we subtract that away, we get 82. So we have 82 centimeters squared. Multiplying it now by my height, which is 1.5 centimeters. And multiply that by 1.5 to get 123 centimeters cubed. Notice I've got cubed on my answers. Be sure to write your units. 123 cubic centimeters. Okay, we'll move on. Looking at number 2, I've got a lunchbox, an old-fashioned lunchbox. You can see the dimensions are given there. The dimensions are 12 inches, 12 inches long, 6 inches wide, 5 inches tall. And this, although it might not be exactly, we're gonna assume that that is a half of a circle. So this is just a half of a cylinder, right? That's a half of a cylinder right there. So if I were to kind of put that there, you can kind of visualize that that cylinder is. So again, we're going to break this now into parts, similar to what we did with area last chapter. We're going to look at the rectangular. We're going to look at the rectangular prism. We're going to find the volume of it. So we'll find the volume of that rectangular prism. So in blue, it's this right here. And then that's the rectangular prism. And then we will look at the half a cylinder. Notice that that's a half a cylinder, so we'll find the volume of half the cylinder. And then with any luck, we'll be able to add those together and have the volume of the lunchbox. And the volume of the lunchbox is the most important part. That's where all the food is kept. So let's take one at a time. Let's start with a rectangular prism. Rectangular prism, the volume equals, big key for these problems this chapter, okay, is to show your work. So the volume equals area of the base times the height. Now what is the area of the base of this? Well, the base is this right here. Right? That's the area of the base, which is 12 times 6. So 12 times 6 is 72. 72 inches squared is my base. And my height is 5. So 5 inches tall. So 72 times 5 is 360 inches cubed. Okay. Now let's go to find our cylinder. Our cylinder, it is a C&P flat top, so I'm going to also take the area of the base times the height. Now what is the base now? The base is going to be this, right? That part right there, which is 1/2 of a circle. 1/2 pi r squared. So I'm going to take 1/2 pi r squared times height. Nice way to prepare yourself for physics in some of the science classes is to get practice writing out the formula and plugging in your values later. So here we go. Now let's plug in the values. What is my radius? Well, the radius is from here to here, right? Which is the same thing as from here to there. So since this is 6 all the way across to 6, that radius must be 3. So got pi times 3 squared times my height. What is the height now? Well, now are referring to our height as how long that C&P flat top is. The height is 12 times 12. So I get, this is going to be 4.5, because that's a 9 divided by 2, 4.5 pi times 12. So 12 times 4.5 is 54. 54 pi inches cubed is my volume. And now we're going to find the total. We find our total by adding them up. So total volume is equal to 360 plus 54 pi inches cubed. Always leave your answer exact in terms of pi or roots whenever you can, unless the application warrants differently. Okay, one last example. Here's another example, number 3. An ice cube, oh, should have been the E on that. Ice cube manufacturer makes ice cubes with holes in the center of them. Each cube is 4 centimeters on a side, and the hole is 2 centimeters in diameter. Okay, what do we want to find? Well, I guess I didn't write what we want to find here. So we're going to find how much water is used. How much water is used in the ice cube. Let me draw a picture of this. So this is, we have a cube. Okay, so we have a cube there, all right, and then we have, maybe you've seen these at a restaurant, you see that there is a hole that comes right out of the center. That's just so the machine freezes the ice quickly with that hole in there. So we want to know how much water is required in this cube. So let's put our units to it. This distance is 4 centimeters. This distance is 4 centimeters. And this one is 4. Okay? Well, you may have guessed it already. We're going to take the volume. We're going to take the volume of the cube and subtract the volume of the cylinder. What's the volume of the cube? The volume of the cube is going to be 4 times 4 times 4, 4 cubed, minus the volume of the cylinder. All right. I need to give you one more piece of information there on the size of that cylinder here. Okay, the hole is 2 centimeters. Need to check my notes there. The hole is 2 centimeters in diameter. So this right here is 2 centimeters. So with that, now I can find base, or my pi r squared times height. So 4 times 4 times 4 is 64. This is 64 centimeters cubed minus pi times my diameter is 2, my radius then is 1 squared, and my height is 4 centimeters. So I have 64 centimeters cubed minus 4 pi centimeters cubed. And there is my answer. Okay. Now here's an example. We like to leave our answers exact, but in the application I have a hard time wrapping my mind around what that is exactly. So I'm going to write its decimal equivalent. It is approximately 51.434 cubic centimeters. Okay, of water goes into one of these cubes. Okay, it's a pretty large cube. All right. So with that, this will conclude just a few examples to help you if you are having a difficult time. All right. See you in class tomorrow.